Good morning, class. Today we are going to see the last topic of this chapter, that is hydrogen bond. When the terms comes hydrogen bond, in your mind it might be there that the bond between the hydrogens, okay, but actually it is not. Now let us see what is hydrogen bond. Hydrogen bond is the electrostatic force of attraction between hydrogen atom of one molecule and a highly electronegative element such as nitrogen, oxygen, or fluorine present within the same molecule or another molecule of the same or different compounds is known as hydrogen bond. So hydrogen bond means the bond which is found between the hydrogen, one atom should be hydrogen, and the other atom will be a highly electronegative element such as nitrogen, oxygen, or fluorine present within the same or it can be different molecules. Say for example, if you see this HF molecule, hydrogen fluoride bond, HF bond, this is also HF bond. Now the bond that is formed between this fluorine, which is a highly electronegative element, and hydrogen, which that will be called as hydrogen bond, and this HF bond, the bond between hydrogen and fluorine, will be called as covalent bond. Remember that one most electronegative element and hydrogen will form a hydrogen bond, and hydrogen bond is shown by a dotted line, okay, in contrast to a thick line representing a covalent bond between atoms. For example, the hydrogen bond in hydrogen fluoride may be represented as follows. Conditions for hydrogen bond. What is required? Number one, highly electronegativity of the atom bonded to hydrogen atom so that bond is sufficiently polar. So the atom that is bonded to hydrogen should be highly electronegative, like fluorine, oxygen, nitrogen. Number two, small size of the atom bonded to hydrogen so that it is able to attract the bonding electron pair effectively. And the size of the atom that will be bonded to hydrogen, that means the electronegative elements should be smaller in size so that it effectively form bonding electron pair. Only nitrogen, oxygen, and fluorine form a strong hydrogen bond because they have high value of electronegativity and small atomic size. There are two types of hydrogen bonding. One we call intermolecular hydrogen bonding, and other we call intramolecular hydrogen bonding. So first we'll discuss about intermolecular hydrogen bonding. Intermolecular hydrogen bonding, this type of bond is formed between the two molecules of the same or different compounds. So this type of bond is formed between the two molecules of the same or different compounds. For example, some examples of the compounds exhibiting intermolecular hydrogen bonds are hydrogen fluoride, HF. In solid state, intermolecular hydrogen bonding means the bond which is formed between the two molecules of the same or different kind. In the solid state, hydrogen fluoride consists of a zigzag chains of molecule associated by hydrogen bond as shown below. So this dotted line are hydrogen bonds, okay, and they have been seen by a zigzag chains. Next, water molecule H2O is represented as this one, where oxygen is electronegative and hydrogen is positive. Now this oxygen can link with other hydrogen molecule, okay, so this will be a hydrogen bond. Similarly with this one. In ammonia also the same thing. Nitrogen is electronegative, so nitrogen can form hydrogen bond with hydrogen. Next is intramolecular hydrogen bonding. Intramolecular hydrogen bonding, this type of bond is formed between hydrogen atom and nitrogen, oxygen, or fluorine atom of the same molecule. So the bond will be formed within the same molecule. This type of hydrogen bonding is commonly called chelation and is more frequently found in organic compounds. Intermolecular hydrogen bonding is possible when 6 or 5 membered rings can be formed. Say for example, we have taken orthonitrophenol. At ortho position we have got a nitro group and this is phenol OH. Now over here in nitro we have got oxygen and in OH we have got hydrogen. So this is electronegative, so they can form a hydrogen bond between them. Now This kind of bond, which is formed within the same molecule, it has not attached to the other molecule. So they are called as intramolecular hydrogen bonding. So this one example. Second example is this one, salicylic acid, salicylaldehyde. Okay. So they are formed hydrogen bond within the same molecule. Intermolecular hydrogen bonding decreases the boiling point of the compound. So if intramolecular hydrogen bonding is formed, intramolecular hydrogen bonding is formed, this will decreases the boiling point of the compound. The reason is that it cannot combine with the other of the same type and form a long chain, which increases the molecular weight of the compound, and that leads to increase in the boiling point. So intramolecular hydrogen bonding decreases the boiling point of a compound and also its solubility in water by restricting the possibility of intermolecular hydrogen bonding. Orthonitrophenol or 2-nitrophenol is more volatile than paranitrophenol. You need to explain it. That means orthonitrophenol is more volatile. That means it evaporates easily or vaporizes easily than paranitrophenol. Okay. Now in the para form, nitro and phenolic groups are maximum distance apart. So in paranitrophenol, this phenol and this nitro groups are very far away from each other, are maximum distance apart. This molecule show intermolecular hydrogen bonding, so they can show intermolecular. That means it can combine with the same type of molecule and form intermolecular hydrogen bonding. The association of molecule take place. So this association of the molecule will take place, which forms a long chain, increases the molecular weight, and the boiling point increases. And if the boiling point increases, it will be less volatile. Whereas in case of 2-nitrophenol, what will happen? It will form an intramolecular within the same molecule. So what will happen? It is not able to form a long chain. So the molecular weight does not increases. So the boiling point decreases. So it becomes more volatile. So their molecular weight increases and hence boiling point increases. In ortho form, nitro and phenolic groups are very near to each other. This way intramolecular hydrogen bonding association does not take place. Their molecular weight remains the same and hence boiling point do not increase too much. Thus ortho form has low boiling point and hence more volatile than para form. Hence the two isomers can be separated by steam distillation. Importance of hydrogen bonding. Number 1. Life would have been impossible without liquid water, which is the result of intermolecular hydrogen bonding. So the water is present in the liquid itself because of the intermolecular hydrogen bonding. Hydrogen bonding increases the rigidity and the strength of wood fibers and thus makes it an article of great utility to meet requirements of housing and furniture. The cotton, silks or synthetic fibers also owe their rigidity and tensile strength to hydrogen bonding. Most of our food materials such as carbohydrates and proteins also have hydrogen bonding among their molecules. And lastly, hydrogen bonding also exists in various tissues, organs, skin, blood and bones. Today's assignment, assignment 18. Define hydrogen bond. Question number 2. Explain the following types of hydrogen bonding with example: intermolecular hydrogen bonding and intramolecular hydrogen bonding. And question number 3. Explain why orthonitrophenol has less boiling point than paranitrophenol. And lastly, mention few importance of hydrogen bonding. So complete this assignment and